queen does not exist, hence it is equal to 0. Probability of selection of the card number 7 who are spared by using total by using the law of addition of probability, we can get this. Okay, at my last problem we come across this application of total probability in estimating the probability of home quarantined persons and as well as hospitalized quarantined persons. Okay, with this the concept of probability and their applications in solving the problems. Okay, now please wait. Okay, now let us enter into the next topic. Already know from our course name, that is random variables. Okay, next the topic is the concept of a random variable. Okay, what is random variable? What is random variable? Okay, a random variable, is a mathematical tool used to transform all the elements in sample space S onto a real axis. Okay, a random variable is used as some mathematical tool used to transform all the elements in sample space onto a real axis. Okay, random variables are represented by capital letters. They are represented by X, Y, or Z, and the elements in the sample space are represented by small letters. Elements are represented by small letters X, Y, Z. Okay, I have missed one thing here, the definition of random variable. A random variable is used as a mathematical tool used to transform all the sample space onto real axis. One point I missed here, by some rule. I missed it. No, I had it. By some rule, we map all the elements sample space onto a real number line. Okay, and how it is being denoted here? Random variable, capital letter X of small s. Okay, capital X of S. A random variable is denoted like this. Okay, now let us enter into the simple example problems. Okay, first example problem. Let us start with some example problem. Here we are conducting two experiments simultaneously. One is flipping a fair coin and rolling a dice. In flipping a fair coin, what are the two distinct outcomes? One is head, the other one is tail. If ever we roll a dice, what are the 6 distinct outcomes? 1, 2, 3, 4, 5, 6. Isn't it? And in this combined experiment, two things happened simultaneously. And we apply some rule. Based upon that rule, we map all the points in the sample space onto real number line. Okay, That is the role of a random variable, where random variable is also a real function. Okay, what is the experiment here? Experiment is an experiment consists of flipping a fair coin and rolling a fair dice. Okay. Yeah, we are doing two different things. One is flipping a coin, other one is rolling a dice. Then we need to apply some rules here. What are the rules applicable here? Say for example, rule 1. We define like this: rule 1. Rule 1. If head occurs, the value assigned is equal to positive and magnitude is equal to the number that shows up on the dice. Okay. Rule 1 states that if head occurs, then value assigned for the concerned element is equal to positive and the magnitude same as the number that shows up on the dice. What is rule 2? If tail occurs, then the assigned value is equal to negative and same as the magnitude that shows up on the dice. Okay, that shows up on the dice. Rule 2 says that the value assigned for the corresponding elements in the sample space equal to negative and the magnitude is same as the number that shows up on the dice. Now, based upon these two rules, we need to obtain the mapping. Okay, first let us first indicate all the sample space elements, then we go for mapping. Okay, elements here. What are the elements we'll be getting here? What are the elements we'll be getting? If your head occurs here, head occurs h comma 1, h comma 2, h comma 3, h comma 4, h comma 5, h comma 6. If tail occurs, what are the events here? T comma 1, T comma 2, T comma 3, T comma 4, T comma 5, T comma 6. It is the different sample space, yes. Okay. All these represented within rectangle box. How many elements in the sample space here? This side 6, this side 6. Totally 12. All these elements should be assigned to some real value based upon these two rules. Okay, first let us draw this real number line. Okay, real number line with the values 0, 1, 2, 3, 4, 5, 6. It is x real axis. To other side, negative values are -1, -2, -3, -4, -5, -6. If head occurs as mentioned in the rule 1, what is the value I assigned for the first element h comma 1, h comma 1? What is this magnitude here? 1. Hence, this one should be mapped to 1. Similarly, h comma 2 is mapped to 2. Similarly, 3 is mapped to, third element is mapped to 3. Similarly, h comma 4 is mapped to 4 value. Similarly, h comma 5 is mapped to 5. Similarly, h comma 6 is mapped to 6. Okay. Observe here we need to note an important point where for single element in the sample space we have unique value on the real axis. Should not go for multi-valued, for where one point in sample space should be cannot be mapped to more than one point in the sample here real number line. Okay, it should be one-to-one mapping. It is called as one-to-one correspondence. For one element in the sample space, we have unique element on the real number line. Similarly, what is t comma 1? T comma 1 as mentioned in the rule 2 here. It is mapped onto the negative and same as the number that shows up. T comma 1 is mapped to -1. Similarly, t comma 2 is mapped to 2. T comma 3 is mapped to -3. T comma 4 T comma 5 is mapped onto -5. T comma 6 is mapped onto -6. Observe here 12 elements in the sample space. Okay, excuse me. Please excuse me. We are in continuation. Sorry for the interruption. The sheet has been detached accidentally. We have 12 elements in sample space are mapped onto 12 points distinctly on the sample space. Okay, hence from this here we can observe the mapping tool which is marked here as x, as specified. I already specified in the definition, where x is some transformation function which maps all the elements onto the real number line by some rule. Okay. You can also observe one more note point here. Say 12 values, 12 elements in the sample space will have 12 distinct values in the real axis. That means it is nature is discrete random variable. You cannot find any intermediate values here. We find only 1, 2, 3, 4, 5, 6. To other side -1, -2, -3, -4, -5, -6. We cannot find intermediate values, something 1.7, 2.8 like. Okay, now let us move on to the another example problem. Example 2. First I will go with some oral presentation, then I will directly go with some pictorial representation. We have a game wheel of chance. Numbered from 0 to 12. Okay, with the transformation function x of s is equal to s square. And this should be mapped onto real axis. Okay, a game wheel of chance. How it is being numbered? It is numbered from 0, one is 0, the other one is 3, the other one is 6, the other one is 9. What is real axis here? Real axis is something 0. Okay. If the given transfer function x of s is equal to s square, then while substituting this value 3 here, what is that value? Get it by some rule. 3 square. What is the value? This value is 9. What is 6 square? 6 square is 36. Similarly, we get all the points in continuum range onto the real axis. Real axis, okay? This is real axis. Via mathematical tool, that is x. Okay? Okay, what is the upper bound? 12 square. How much the value? 144. Observe here, we have all the points in sample space are mapped onto a real axis. Hence it is continuous random variable, because we can have the values right from 0 to 144. 0, 0.2, 0.3, 0.4, likewise. That means example 2 is an example of continuous random variable. What is example 1? Discrete random variable. What is example 2? Continuous random variable. Okay? Here it is shown like this here. A game wheel of chance numbered from 0 to 12. And these are the values obtained from the given elements in the sample space. You can call these elements in sample space as domain, and all the elements in the range on the real axis set to be range or codomain. Okay? Example 1 is a continuous random variable. Example 2 is a discrete random variable. Okay? Okay, next we just enter into some simple classification. What are the classifications of random variables? Classifications. One is discrete random variable. Discrete random variable. Discrete random variable example is example 1. Why? Because sample space has only discrete values. What are the values here? Minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 1, 2, 3, 4, 5, 6. We have discrete values. Hence, the name is given discrete random variable. Okay? What is B? Is continuous random variable. Continuous random variable. What do you mean continuous random variable? If it contains continuum range of values, as shown in the second figure of second example. Okay, what is the sample space containing here? X of s is equal to 0 less than x less than equal to 144. We have values, range of values right from starting from 0 up to 144. What is C? C is called as mixed type random variable. Mixed type random variable. So mixed type means which is in nature it is containing both the discrete as well as continuum range of values, and that is the name is given mixed. Mixed means a combination of both. Example: x of s is equal to something minus 4, minus 2, 0, 1, 2 less than x less than equal to 40, 50, 60. Observe here, it is containing both discrete as well as continuum range. As the name is given, discrete mixed type random variable. Okay, let us have quick revision with this side here. Here, what is random variable? Random variable is a mapping function or a mathematical tool used to transform all the elements in sample space onto a real number value, where it obeys one-to-one correspondence. For one element in the sample space, we have only distinct one value on the real axis, unique value. Similarly, here in the example, we apply rule 1 and rule 2, we get this figure, where 12 elements in the sample space are mapped onto the 12 distinct values. Hence, the name is given discrete random variable. What is continuous random variable? Where it contains continuum range of values on the real axis, as given in the B. That is represented in the second example. Okay. What is mixed random variable? Mixed random variable contains both discrete as well as continuum range of values. Okay. Okay. With this, today is our third class is over. Okay. In the next class, we shall start our class 4 with distribution function. Before that, we shall start with conditions for a function to be a random variable and followed by distribution function. Okay. Here today we have covered some part problems on probability and statistical independence, and the application of some total probability for the exam problems, and concept of random variable. Okay, in the form of 2 examples and classification of random variables. Okay, if you like this video, you please subscribe to our channel and share it to your friends. Stay home, stay safe. Thank you.